The Lockheed Martin or Boeing F-22 Raptor is an American twin-engine, all-weather stealth fighter aircraft developed and produced for the United States Air Force USAF. As a product of the USAF's Advanced Tactical Fighter ATF program, the aircraft was designed as an air superiority fighter, but also incorporates ground attack, electronic warfare, and signals intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22E's airframe and weapon systems and conducted final assembly, while program partner Boeing provided the wings, aft fuselage, avionics integration, and training systems. The F-22 descended from the Lockheed F-22 and first flew in 1997, and was variously designated F-22 and F-22 before it formally entered service in December 2005 as the F-22A. Although the USAF had originally planned to buy a total of 750 ATFs, it later scaled down to 381, and the program was ultimately cut to 195 aircraft, 187 of them operational models. In 2009, due to political opposition from high costs, a lack of air-to-air missions at the time of production, and the development of the more affordable and versatile F-35, the last aircraft was delivered in 2012. After a protracted development and initial operational difficulties, the F-22 became a critical component of the USAF's tactical air power for air-to-air missions against peer adversaries. The F-22 Raptor, internally designated Configuration 645, is a fifth-generation air superiority fighter that is considered fourth-generation in stealth aircraft technology by the USAF. It is the first operational aircraft to combine supercruisy, supermaneuverability, stealth, and integrated avionics or sensor fusion in a single weapons platform to enable it to survive and conduct missions, primarily offensive and defensive counter-air operations, in highly contested environments. The F-22 Raptor's shape combines stealth and aerodynamic performance. Planform and panel edges are aligned and surfaces have continuous curvature to minimize its radar cross-section. Its clipped diamond-like delta wings are smoothly blended into the angular fuselage with firm empennage surfaces and leading-edge root extensions running to the upper outboard corner of the carrot inlets. The inlet's upper edges also meet the fuselage's four-body chines. Flight control surfaces include leading-edge flaps, flaperons, ailerons, rudders on the canted vertical stabilizers, and all moving horizontal tail stabilators. For speed brake function, the ailerons deflect up, flaperons down, and rudders outwards to increase drag. Owing to the focus on supersonic performance, area rule is applied extensively to the airplane's shape, and nearly all of the fuselage volume lies ahead of the wing's trailing edge, with the stabilators pivoting from tail booms extending aft of the engine nozzles. Weapons are carried internally in the fuselage for stealth. The aircraft has a refueling boom receptacle centered on its spine and retractable tricycle landing gear, as well as an emergency tailhook. Fire suppression system and fuel tank inerting system are installed for survivability. The aircraft's dual Pratt & Whitney F119 augmented turbofan engines are closely spaced and incorporate pitch-axis thrust vectoring nozzles with a range of 20 degrees. The nozzles are fully integrated into the F-22E's flight controls and vehicle management system. Each engine has dual redundant Hamilton Standard Full Authority Digital Engine Control (FADEC) and maximum thrust in the 35,000 lbf 156kN class. The F-22E's high cruise speed and operating altitude over prior fighters improved the effectiveness of its sensors and weapon systems, and increased survivability against ground defenses such as surface-to-air missiles. The airplane's aerodynamics, relaxed stability, and powerful thrust vectoring engines give it excellent maneuverability and energy potential across its flight envelope, capable of 9G maneuvers at takeoff gross weight. Its large control surfaces, vortex-generating chines and lurks, and vectoring nozzles provide excellent high alpha angle of attack characteristics, and is capable of flying at trimmed alpha of over 60 degrees while maintaining roll control and performing maneuvers such as the Herbst maneuver J-turn and Pugachev's Cobra. The computerized triplex redundant fly-by-wire control system and FADEC make the aircraft highly departure-resistant and controllable, thus giving the pilot carefree handling. The F-22 was designed to be highly difficult to detect and track by radar, with radio waves reflected, scattered, or diffracted away from the emitter source towards specific sectors, or absorbed and attenuated. Aircraft's flat thrust vectoring nozzles flatten the exhaust plume and facilitate its mixing with ambient air through shed vortices, which reduces infrared emissions to mitigate the threat of infrared homing heat-seeking surface-to-air or air-to-air missiles. Additional measures to reduce the infrared signature include special topcoat and active cooling to manage the heat buildup from supersonic flight. Compared to previous stealth designs like the F-117, the F-22 is less reliant on RAM, which are maintenance-intensive and susceptible to adverse weather conditions. Unlike the B-2, which requires climate-controlled hangars, the F-22 can undergo repairs on the flight line or in a normal hangar. The effectiveness of the stealth characteristics is difficult to gauge. The RCS value is a restrictive measurement of the aircraft's frontal or side area from the perspective of a static radar. When an aircraft maneuvers, it exposes a completely different set of angles and surface area, potentially increasing radar observability. Furthermore, the F-22E stealth contouring and radar absorbent materials are chiefly effective against high-frequency radars, usually found on other aircraft. The effects of Rayleigh scattering and resonance mean that low-frequency radars, such as weather radars and early warning radars, are more likely to detect the F-22 due to its physical size. These are also conspicuous, susceptible to clutter, and have low precision, 1 for 5 additionally, while faint or fleeting radar contacts make defenders aware that a stealth aircraft is present. Reliably vectoring interception to attack the aircraft is much more challenging. Beginning in 2021, the F-22 has been seen testing a new chrome-like surface coating. This highly polished surface appears to change color based on the viewer's orientation to the aircraft. It is speculated that the new coating will help to reduce the F-22E's detectability by IRST and other infrared tracking systems and missiles. This coating has also been seen on some F-35 and F-117 test aircraft. In order to prevent the inadvertent disclosure of the aircraft's stealth technology and classified capabilities to the US's adversaries, annual DOT appropriations acts since FY 1998 have included a provision prohibiting the use of funds made available in each act to approve or license the sale of the F-22 to any foreign government. Customers for U.S. fighters are acquiring earlier designs such as the F-15 Eagle and F-16 Fighting Falcon or the newer F-35 Lightning II, which contains technology from the F-22 but was designed to be cheaper, more flexible, and available for export. In September 2006, Congress upheld the ban on foreign F-22 sales. Despite the ban, the 2010 Defense Authorization Bill included provisions requiring the Department of Defense to report on the costs and feasibility for an F-22 export variant, and another report on the effect of F-22 export sales on the US aerospace industry. Some countries that showed interest about buying the F-22 were Japan and Australia, because of its known capabilities that could help Japan and Australia's Air Force. The F-22 and its subsystems were designed to be upgraded over its life cycle in anticipation for technological advances and evolving threats, although this initially proved difficult and costly due to the highly integrated avionics system architecture. Currently, the F-22 Raptor is planned to get a $7.8 billion modernization upgrade to most Raptors for preparing for potential war with China. In summary, the F-22 is one of the most advanced and the stealthiest fighter jet in the world. Its dominance will continue with it continuing to get more modernization upgrades, and maybe some more Raptors will get built in the future. There may be a part 2 to this video because it's so long. Anyway, thanks for watching.